The next aspect of hydraulics we're going to discuss is friction loss. When water flows from one place to another in pipe, as in point A here to point B in this image, there's a loss of pressure between the 2 points. The pressure gauge at point B is going to have a lower reading than the pressure gauge at point A, and that pressure loss is called friction loss because it's the result of the forces of friction acting on the water pressure in the pipe. There are 4 friction loss factors that we consider when we're calculating friction losses, and we're going to discuss each of these in more detail. But to introduce them, the first is velocity or flow, the second is the inside diameter of the pipe, the third is the roughness of the pipe materials, and the fourth is the length of the pipe. So the first of those factors, velocity, or flow, which we discussed in the last lecture, is the speed that water's moving through the system, and it's typically measured in feet per second, or FPS. As velocity increases, pressure losses also increase. So, for example, in these images, let's consider friction loss in 2 sections of 1-inch Schedule 40 PVC pipe. In the top image, flow is 8 gallons per minute, resulting in a pressure loss of 1.74 psi per 100 feet of pipe. In the bottom image, the flow or velocity is higher. It's 18 gallons per minute, and the pressure loss is 7.82 psi per 100 feet of pipe. It's significantly higher than it was at 8 gallons per minute, even though the size of the pipe and the material is exactly the same. And by the way, when we talk about friction loss, we typically use units of psi per 100 feet of pipe, but for lengths of pipe that are more or less than 100 feet, the friction loss is simply increased or decreased proportionally. And we're going to go through how you determine that in some later examples. So the second factor affecting friction loss is the inside diameter of the pipe. As pipe sizes decrease, if the flow is kept constant, pressure losses are going to increase. So again, as pipe sizes decrease, pressure losses tend to increase. So in this example, notice that the inside diameter here in this 2-inch Schedule 40 PVC pipe is actually 2.047 inches. So let me just discuss that for a minute. When you're purchasing this pipe and looking in catalogs, it's also often going to be labeled just 2-inch Schedule 40 PVC. But that 2-inch is the nominal size of the pipe, meaning it's just for identification purposes or naming purposes. The actual ID, or inside diameter, of this pipe is 2.047 inches. Okay, so let's take a look here. The flow rate in this pipe is 15 gallons per minute. The flow rate in this pipe, which has a smaller inside diameter, is also 15 gallons per minute. In this case, this is 1-inch Schedule 40 PVC pipe. So the difference in terms of pressure loss, here the pressure loss is 0.19 psi per 100 feet of pipe, but here in the smaller diameter pipe it's up to 5.60 psi per 100 feet of pipe. So a very significant difference in terms of pressure loss. A third factor that affects friction losses in pipe is how rough or smooth the interior surface of the pipe is, so the surface of the pipe that's actually contacting the water. This is specified by a roughness factor that's designated as C. So you see it noted here, C. And the higher the C factor is, the smoother the pipe is. The lower the C factor is, the rougher the pipe is, and the more friction losses there will be. So here we've got 2 pipes that are the same size. One has a C factor of 150 and one has a C factor of 100. The flow in both of these pipes is 10 gallons per minute, but note how different the pressure losses are because of the different roughnesses. So here, when the roughness is, the C factor is 150, pressure loss is 2.63 psi per 100 feet of pipe. And here, where the C factor is 100, the pressure loss is 5.08 psi per 100 feet of pipe, so just about double. So the smoothness of that pipe is a big factor in terms of friction loss and pressure loss in pipe. The last factor related to friction loss is the length of the pipe. And I think this makes pretty good intuitive sense. The flow through a longer pipe is going to result in more friction loss, and this is true for all types and sizes of pipe. So for example, here you've got two lengths of pipe, 100 feet and 200 feet. The materials are the same, but the pressure loss measured over 100 feet of pipe is 2.63 psi total, and here we don't have to say per 100 feet of pipe because we do have actually 100 feet of pipe. Here, on the other hand, pressure loss measured over 200 feet of the same pipe is 5.26 psi. It's double what it was for 100 feet of pipe. All four of the factors that I've just talked about, velocity, inside pipe diameter, pipe surface roughness, and pipe length, are used to determine friction loss and ultimately dynamic pressure in an irrigation system. But how are those friction losses determined? We've identified those factors, but the way that the friction losses are actually determined involves the use of several equations. And commonly these are the Hazen-Williams equation, Darcy-Weisbach equation, and Manning equation. These, however, are generally used for open channel water movement. Irrigation designers may use these equations, but for our purposes there are convenient friction loss tables that are for more general use. And these tables that we're going to go over summarize friction losses across a wide variety of pipe materials, sizes, and velocities, and the calculations have already been done. That's good news for us. Generally speaking, these tables use the Hazen-Williams equation for calculating pressure losses. It's important to note that different sources of these tables may have slightly different values, and that's because of the potential for using different pressure loss equations. So the tables that we're going to go over give you information like the pressure losses due to friction, velocity at various flow rates, and pipe sizes using pressure loss and velocity. So what do these tables look like? Here's a sample of a friction loss table, and these are going to become very familiar to you. They're very important when you're choosing materials for your irrigation designs. So let's go over the various pieces of information step by step. Okay, first of all, A. Let's begin with A, and we'll go through it in alphabetical progression. A is going to indicate here, this is the type of pipe. It's typically noted at the top of the chart, and in this case we've got a Class 200 PVC IPS plastic pipe. B indicates or iron pipes, IPS, iron pipe size, indicates that the pipe's outside diameter dimension corresponds to that outside diameter of iron pipe. All PVC IPS pipe of the same nominal size has the same outside diameter. For example, all 3/4 inch PVC irrigation pipe has an outside diameter of 1.050 inches. So all 3/4 inch slip fittings will fit on the outside of all types of 3/4 inch PVC pipe. C here refers to the standard by which the pipe is manufactured. So ANSI or ASAE standards, those stand for American National Standards Institute, and in this case ASAE stands for the American Society of Agricultural Engineers. D, SDR, or standard dimension ratio, indicates the pipe wall thickness as a ratio of the outside diameter. If you divide the outside diameter by the wall thickness, it will give the standard dimension ratio, or SDR. All pipe with SDR 21 has the same pressure rating of 200 psi, for example. Alright, now moving on to E. Here is the roughness factor that we went over, that C factor. Again, the lower the number, the rougher the surface of the inside of the pipe, and the greater the pressure loss. For PVC, C is equal to 150. For standard steel pipe, which is much rougher, the C factor is equal to 100. Okay, moving on to F. That just indicates that this chart is giving you values of PSI loss per 100 feet of pipe. Okay, so next, G. Let's see, G, size. This indicates the nominal size of the pipe. So none of the listed pipe dimensions are exactly that size. So let's say in this column, none of these are actually 3/4 inch. And we discussed that when I was going over some of the factors with friction loss here. H indicates the outside diameter of the pipe. I indicates the inside diameter of the pipe. J indicates the wall thickness of the pipe, and these are all noted over here on this on the left-hand column of the chart. And K indicates the flow rate of the pipe. In this case, the units are gallons per minute. L indicates the velocity or flow of water at the corresponding flow rate. So here, let's say, for example, in this row, you've got a flow of 3 gallons per minute. That corresponding velocity is 2.53 feet per second. We'll go over that a little bit more. M indicates the PSI loss per 100 feet of pipe at the corresponding flow rate. So in this case, let's look at this row. The flow is 5 gallons per minute. As you move across this row, the PSI loss at 5 gallons per minute for this particular size of pipe is 4.89 PSI per 100 feet of pipe. Okay, now let's talk about this shaded area a little bit. All of the flow charts that you're going to look at have that shaded area, and what they indicate is the flow rates here for these particular pipe sizes exceed 5 feet per second. So you see here along this column the velocity. Once you get past 5 here in this pipe size, it exceeds 5 feet per second. Same here for 3/4 inch. Once you get past 12 gallons per minute, it gets above 5 feet per second, and that's shaded to indicate to you that you don't want to go beyond that. That 5 feet per second is a general rule of thumb that you don't want to exceed, because it can cause problems like water hammer, particularly in main lines, and those kinds of problems can wear out pipe and other components more quickly and can even cause breaks. So that shaded area is sort of an indication of caution that you don't want to exceed that particular flow. So you might want to make another pipe choice as a result. So let's go over how you use these charts in a little bit more detail, do an example or two. So the order that you're going to use the chart in is, first, find the right table for your pipe material and type. So that was indicated at the top there. Second, you're going to find the flow rate that you need for a sprinkler or sprinklers. You're going to find the corresponding column for the size of pipe. You're going to find the pressure loss corresponding to the specific pipe size, and then find the corresponding row for flow. So having said all that, let's go through an example. Let's find the friction loss in this particular pipe if the flow is 6 gallons per minute and the nominal pipe size is 3/4 of an inch. Okay, so first you'd find the correct friction loss chart, and there are a series of these in the back of your textbook. They're also available online. So here is that chart for the particular kind of pipe we're looking for. Next, you'd find the flow rate of 6 gallons per minute. That's right here on the left-hand column. And you also find the left-hand, and you'd also find the column for the nominal pipe size of 3/4 inch, which is right here. Now you're going to read down this column of flow until you get to 6, and then you're going to read across until you get to the right column for your 3/4 inch pipe size, and that's this point here indicated by 3, and it reads 1.86 PSI loss per 100 feet of pipe. So that's how you would determine how much pressure is lost for that particular pipe size at that particular flow rate. Let's do another example, because it's going to be really important that you know how to use these charts. So this one is similar to the last example, except that we're going to start by assuming the pipe length is 42 feet. Okay, so same flow rate of 6 gallons per minute, same pipe size of 3/4 inch, but we've got a pipe length of 42 feet. And this is more realistic, I'd say, because it's pretty rare you're going to have a pipe length of exactly 100 feet in your designs. They may be shorter or longer, but in either case, you need to learn to use the PSI loss from a chart like this along with your pipe length. So you've got the correct chart here. You'll start again by finding the flow rate in the column on the left, which is 6 gallons per minute. And you'll find the correct pipe size column, which was 3/4 inch. So moving across there, we see that our friction loss is 1.86 psi per 100 feet. Okay, but we're working with 42 feet of pipe in this example, so we'd go the additional step of taking that 1.86 psi loss and dividing that by 100 to get our psi loss per 1 foot length of pipe, which in this case equals 0.0186, and then multiply that by 42 because we've got 42 feet of pipe, right? So then we end up with a loss of 0.78 psi. What if you had something different? What if the length of the pipe were 192 feet? Then you'd simply take this 0.0186 and multiply it by 192 to get the resulting loss in psi. Alright, so summing that up, there are 4 factors that are going to affect friction loss in pipes. Those are velocity, inside diameter of the pipe, roughness of the material, pipe length. And you're going to use tables or charts of friction loss that are the most common source for these values, as opposed to going through the trouble of calculating them yourself. Here's a little something to think about, and we will move on to the next section on dynamic pressure.